Good morning, class. My name is James Aguirre from the Operating Engineers, and I'm going to walk you through how to do a sand cone as per ASTM D4959. And we're going to start with the calibration of the sand. All right, now prior to filling our measure with sand, in order to calibrate the sand, we need to get a tare weight of the 1/10 of a cubic foot measure, and we're going to do so in grams. And we see there that I got 1,690 grams for the tare weight. Now using our sand cone, we're going to fill up the 1/10 of a cubic foot measure with the sand using the sand cone until it's all the way full, and then we're going to strike it off after complete. Okay, here we see the sand has stopped flowing out of the cone, so we know that we have a full measure below. I'm going to close it. Now we need to strike it off flush in order to get the proper weight into the mix. And after filling the measure, we now have a weight of 5,627 grams. Okay, so just like we calibrated the unit weight of the sand, we also need to calibrate the weight of the sand in the cone and plate. Because when you perform your actual sand cone test, that portion of the sand will not actually be going into the hole that you dig. And as you see over there, inside of our tray, we have placed a magazine below the plate, because we want to capture only the amount of sand that's going to fall in the cone and plate. So to start with, we're going to do a tare weight of a full sand cone prior to filling the cone and plate. And I'm getting a full weight of 13.160 pounds, and we are taking this to the third decimal place. Alright, so now I'm going to open the valve and let the sand within the bottle portion of the sand cone fill up the entire cone and plate below, and we are going to turn off the valve once the sand stops filling the cone and the plate. Okay, so I have been very careful in order to perform this test in a vibration-free area, and I'm visually observing that the level of the sand has stopped going down within the bottle and is no longer moving, which another term for that is it has now stabilized. So we know that the cone and the plate portion of the sand cone are now full. So I will close the valve, lift it up, and then get my net weight after filling the cone and the plate. And my weight after filling the cone and the plate is 9.796 pounds. Okay, so in order to get the weight of the sand and cone and plate, you're going to get your gross weight before and then subtract your net weight after. So you have 13.160 pounds, subtract 9.796 from that, and you get 3.364 pounds of sand in your cone and plate. And this is just one trial. Were you to actually be doing this in the field, you would need to do an average of 3 trials, and the average of those 3 numbers would be the number that you would use when performing your sand cone test calculations. So prior to going out into the field to start my actual sand cone test and dig the hole, I need to record the amount of sand in the cone and plate. So I've recorded the 3.364 in item number 4 under volume of hole, and then I also need to weigh my full sand cone prior to starting my test. And I'm getting a weight of 12.468 pounds. And that is being recorded in item number 1 under volume of hole. Okay, now we're out in the field and we're going to get ready to dig our hole for our sand cone. To start with, we want to make sure we have our nice level, flat, compacted area. In this case, we're going to be testing at a finished subgrade, so I did not need a machine to dig me a test hole, but I got my little spot here. I use the plate upside down to kind of rake it across, make sure it's nice and flat. And then there's a few tools I'm going to need: small hammer, a couple grade nails to secure my plate, and then I got a trowel, I got a large spoon, screwdriver, brush, measure in order to verify I have my proper 4 to 6 inch depth of hole, and of course my full cone. Now we're going to secure the plate. Okay, so now I'm going to begin digging my test hole, and I got an empty cylinder here which I'm going to use to deposit the contents of my hole. I need to deposit all the contents from the hole that I dig into this empty measure. This has already been tared, and we would have recorded that tear weight on our sand cone data sheet as well. And I'm trying to dig about 4 to 6 inches deep. Nice circle, removing all the contents, placing it into my empty cylinder. Alright, digging of the hole is complete. Now I'm going to turn the sand cone upside down and start filling the measure. Want to start it here, and you want to keep going until you see the sand stop filling. Once it levels off and you see the movement of the sand stop, you know that both the hole and the cone and plate have been filled. Okay, so I have capped the cylinder that's holding all the soil that's been removed in the hole, and the reason we place the cap on there is we want to preserve the moisture, so when we go back and do our moisture burn off, it is going to be accurate of the condition that the soil was when it was removed from the hole. We see here on my cone that the level has stabilized, so we know that both the hole and the cone and plate are now full. Going to close the valve and remove the cone. What's left on top is representative of sand and cone and plate, and we perform our calculations later. That will be calced out. That's why that number is already written down on our sand cone data sheet for it. So prior to going out into the field, we needed to get the tare weight for the empty cylinder in which we were going to place the soil removed from our hole. Looking here on the scale, I see that I have a tare weight of 0.592 pounds, which is going to go in item 8 under wet density on weight of bucket. Now, after digging the sand cone and removing the soil, we're going to remove the cap and weigh it after to find out how much soil was removed from the hole. So the weight of the bucket and the soil is 7.132 pounds. And now that I'm returned to the area where I have my scale, I also need to weigh the sand cone after so I can find out how much sand was used during the test. Upon weighing it after, I get 4.752 pounds. Which is going to go in item number 2 under volume of hole. Okay, now we're going to walk through the calculations. My weight of sand and cone before was 12.468 pounds. My weight after was 4.752. I subtract item 1, subtract away item number 2, and you get 7.716 pounds. Now we're going to subtract away item number 4, and you're going to get 3.364 pounds, which leaves weight of sand in the hole at 4.352 pounds under item 5. And then item 5, you need to divide by A, which is our 86.8 pounds per cubic foot, which is our unit weight of sand. And upon doing that, our volume of test hole was 0.050 cubic feet. As for our weight of soil in under wet density, we're going to have weight of soil and bucket 7.132. You're going to subtract the tare weight of the bucket, or in this case a cylinder, of 0.592. You're going to get weight of wet soil at 6.54, and then you do 6.54. You're going to divide that by the volume of your test hole of 0.050, and you're going to get a wet density of 130.8 pounds per cubic foot. So now we have a wet density, but we're going to have to start a burn off in order to establish a dry density, which is one of the most important purposes of performing this test. Okay, our next step is going to be to tare the measure in which we're going to perform the burn off in. So we're going to switch back to our grams now, because this part is going to be performed in grams. I have already placed a rag here in order to prevent the scale from getting burnt, but if you place the rag prior to turning on the scale, you will still start at 0. I put the pan on there, and I'm getting a tare weight for weight of tare under item 13 is going to be 353 grams, as shown here. Okay, I have deposited the entire contents of the cylinder that I used to remove the soil from the hole, and I put it here, and now I'm going to take 500 grams worth of that soil and put it into my pan for the burn off. I now have a full pan at 853 grams. Alright, we have now turned on our single burner and we're going to begin burning the 500 grams of wet soil. It's in a dry condition now. It's in a wet condition. We're going to burn it until it's dry. Every minute or two, you're going to have to stir it a little bit with the spoon in order to evenly burn it, because you want to get all the moisture out and you don't want the moisture to remain within the soil, within little clumps. So keep mixing as it burns. We're going to burn for a while. We'll show you halfway through and we'll show you how it looks as it's dry. Alright, as we're cooking the soil, I'm using the spoon to break up any clumps and kind of mix it around a little bit so that we can evenly cook it, because when we're all done, we want to end up with a dry, constant mass, and the only way to do that is to make sure to cook the entire contents of the burnout sample. And you want to burn it until it appears completely dry, and then check it. But even at that point, you're going to have to burn it for a few more minutes to make sure that you really got all the moisture out of it. Okay, we've now cooked the soil into what appears to be a dry condition. So we're going to check it once, and then we're going to burn it off for a few more minutes and make sure that we've achieved a constant mass. I now have 818 grams. I'm going to write that down here first. And item number. Alright, I've now burnt the soil for about 5 more minutes, and we're going to weigh it again to confirm that we have now achieved our constant mass. I'm still at 818 grams, as you can see there. So based on that, I have achieved my constant mass, and now we're going to walk through the calculations necessary to determine the dry density. Okay, so now we're going to walk through the moisture content calculations. My weight of wet soil and tare was 853 grams. My weight of dry soil and tare in item 12 was 818 grams. My weight of my tare, my pan, was 353 grams. So when you do 11 minus 12 to come up with the weight of water, that's your before and after cooking, the difference there is going to give me 35 grams of water for item number 14. And then you're going to do, to get your weight of dry soil, you're going to do item 12 minus item 13. You're going to get 465 grams. And in order to get your moisture content, you're going to divide the weight of water, 35 grams, divided by the weight of dry soil, 465 grams. That's going to give you 0.075. And in order to convert that to a percentage, you're going to move the decimal place 2 places to the right, and you're going to get 7.5% moisture. And under item number 17, our theoretical optimal moisture for the purpose of today's example is going to be 8.5%, and our theoretical maximum density is going to be 131 pounds per cubic foot. Okay, now we're going to walk through the final set of calculations in order to get our dry density. So under item number 18, in order to get a dry density, which we've calculated to 121.7 pounds per cubic foot, we took 100 and then we multiplied it by the cumulative quantity of item number 10, which is 130.8, and then we divided by the number 100 plus item number 16, which is 7.5. So you have darn it, don't like it. Alright, so now we're going to calculate the dry density and the relative compaction. So I'm getting under item 18 a dry density of 121.7 pounds per cubic foot. And the way that I calculated that, first we're going to start inside of the brackets here. So you're going to have, it shows you that you have in the inner brackets 100 plus item 16. Item 16, as shown here, is 7.5. So that is 100 plus 7.5 is 107.5. and then it tells me to do item number 10, which is 130.8 divided by 107.5, and I'm going to get 1.217. And then on the outside we have our 100, so you times by 100, and you're going to get 121.7 pounds per cubic foot, which is your dry density. Our example for this calculation is going to be a max density of 131 pounds per cubic foot. So if you divide 121.7 by 131, you're going to get a relative compaction of 92.9%. And for our example 2, we have a 90% required compaction, so 92.9 would be a passing test.